the yes. So today, yeah. So last week we discussed stacks in stacks. The main concept that has been used is LIFO. So I told you it could be LIFO, that means last in, first out, or first in, last out. The opposite of this. Both can be used, but as a standard, we use this last in, first out, LIFO. So I told you stack is an abstract data type. So that means we are discussing an abstract idea, just an idea in an abstract level, right? Stacks, so there are several operations, right? In stacks, we have push, pop, and then peek mainly, right? So push means add a new element onto the stacks and place it on the top, right? On the top. So then pop means retrieve elements on top of the stack by removing it, right? So this is the idea, right? This is the idea. Stack should be something like this. That's what we talk. Then it can be implemented using different approaches. මෙන්න මේ concept එක තමයි stack කියලා අපි කතා කරන්නේ. ඊට පස්සේ implement කරද්දී implement කරන එක අපිට කරන්න පුළුවන් එක එක විදියට. So last week we implemented it using arrays. And I told you it can be implemented using linked list as well. So linked list, so we are going to learn, if possible, I'll introduce today. And then next week we will discuss linked list, right? So I told you, like, I'm going to give you the assignment 2, but then I realized without knowing a linked list, so you cannot complete that assignment. So I'm going to upload it next week. So after discussing linked list, okay. Right. So this we implemented using arrays. Right? So here in this example, it is long type array. Okay. So however, the type can be decided based on your requirement. Right. In this case, so we are creating long stack. So that means long type values can be stored in this stack. So you can use char or string or whatever the values that you are going to store in this stack, or any other object types. Suppose if you are going to add student objects, or patient objects, or whatever the object types, so the type can be different based on the requirement of the application. Okay, so mainly we talked about push, pop, and peek. So can anyone tell me what is the difference between pop and peek? Pop and peek. Can anyone tell me? Pop and peek. What's the difference? Pop removes the item while peek just look at the item. Peek will give which value is on top. Yeah. Pop will decrease the index by 1. Peek will display the last element. Yeah. Yeah. Thank you, Akila, Vitushan, and Harshan. Right. So that's correct. So pop removes. Actually, we are not removing. So we talked about that. We are not removing, but actually we are fake. We are displaying that we are removing. Right. So the index is decreased. So now the top item is the previous item, right? The top item, the previously top item has been removed, right? So that's what we do with this. But in peek, we don't remove the top item. We just show what is on top. What is on top? Like we are just looking at the top item. That's all. But in pop, we are removing the top item. That's the difference. Yeah, pop will delete a top value and give the that value. Yeah. So basically, that's what we have to do, right? Right. So then, additionally, we put is empty and is full. Right. So that's those are two methods that can be used to check whether the stack is empty or stack is full. So they can be, I told you, they can be used in pop and push to validate. Like when you are pushing, when you are put values, if stack is full, then you cannot push more values, right? So then in that case, you can use this method here. Similarly, when popping values, so we pop values one by one, and then if stack is empty, we cannot pop any more values. So then we can check this method. We can use this method to check whether the stack is empty. So I showed you, right? So yeah, like pop, like we can use is empty, and then push we can use is full. Okay, so I expect you to write this program by yourself. Okay, then use proper comments, right? when necessary, and then write your own program. Okay. And today, so let's briefly discuss two implementations. Two examples of so this is the stack, how stack has been used here. Right? Stack X. So we create new stack with the size 10, and then we push values, and then we can pop values. Right? So like in a while loop, we pop until the stack is empty, while loop is iterating. So we pop. So this is a stack implementation, right? So today we are going to discuss two examples. So before going into queues. Right, okay. The first example, reversing a word. So reversing a word, there are several approaches that we can take, right? In reversing a word, so if we have a word, any word, so we input this into our program, and then it will output the reverse. Right? Reversing a word. We can use, we can do this, right? We can write this program using stacks, right? How we do that? So we have to create a stack that can hold characters, char stacks, right? Then we take this word one by one, right? Like we take this word one by one. First, the first letter, and we push it into the stack, and then the second word, second character into push into the stack. So likewise, all the characters put into the stack. Right? Now, so after that, we pop one at a time. First, we pop D. And then we pop R. Then we pop O. Then we pop W. It's very easy. See, first we push all the letters into the stack and then we pop one at a time. That's it. Is stack the only way to do that? No. There are many other approaches. The implementation would be easier, but stack can be used. Stack එක පාවිච්චි කරන්න පුළුවන් මේකට. So let's see the program here. So here we have two variables. We have a class. So I'm not going to implement this. So I'm going to discuss what I have given here. Right. So there are two variables, input and output. Right. Then, so we have, this is the class reverser class. And then in this class, so we have two instance variables, private, right? Then in constructor, so this is a constructor. In constructor, the word can be given. The word to be reversed can be given as a string. Then that variable is assigned to input, this variable. That's what we do here in construct. And then we have a method to review. This is the method that reverses the word. It returns a string, reversed word as a return. So here int stack size. Stack size has to be the length of the string. And then, so in our previous example, so we created stack, right? Stack X. So in that case, stack X. This class can be used. Right? This class can be used in here. See, stack X has been used, but in this case, you can change stack X slightly to have char characters. Characters පාවිච්චි කරන්න පුළුවන් වෙන්නේ මේ stack X කියන එක you change කරලා type එක පොඩ්ඩක් change කරලා පාවිච්චි කරන්න පුළුවන්. So we create stack X object with the stack size, that's the input length. So if we go to this one, so in this case, in my example, I created with int. We can change it to char. That's all. All phrases can be changed. So that's all. Yeah. I know. Maybe yeah, like empty string, so whatever, or null, or whatever. So you can provide empty character, whatever, right? So then, yeah. Yeah. Yeah, that's enough. So I just change it to so here. Yeah, so I'll put null character. Okay. We can use this stack. This stack can be used. Just give me. So I'll just show you the beginning, reversal, right? So, word reversal. Word reversal. Yeah. Yes. So this is the class word reverse. String input and output. And then public. These are instance variables. This is the constructor. Public word reversal. So in constructor, we can take the input string. In or input, you can put the same, right? Doesn't matter. Right? This input. So here we have to put this input. That means this class instance variable input, this input is assigned with this parameter variable. මේ input එක කියන්නේ මෙතන. ඒක තමයි assign කරන්නේ this input කියලා කියන්නේ මේ මෙතන අපි private string input කියන මෙන්න මේක. Okay. So those are object oriented things. Huh? Right. So then public. So here again the method that reverse. Just to inform you, right? So otherwise, I mean, so you can put a better comment here. But there are several good ways to add comments. But anyway, like so here, string is the return type. And then to reverse. Usually, you can put try catch. Right. The output, this dot output can be assigned with empty string. Right. At the beginning, so we can return the output. So here. Output එක තමයි අපි return කරන්නේ. Now the program has been, I mean, it is the structure is there, right? What we have to do is the reversing part has to be there. So here In that case, we have to use stack, this stack class that we do, right? Okay, the first thing, stack whatever the name that you give, right? Here we have to give the size of the stack. Size of the stack has to be input dot length. Yeah. Input dot length. So sometimes this length may be usable in the next line, so we can assign it into a variable, int stack size, something, any variable. This variable can be used here because once this length method is called, so then we can assign it to variables. Then again and again we don't have to call this method. Right? So you can put the length, the size of the stack. Stack object. Now, we have the stack now. Stack can be, so we can push items into stack. What are the items? In this input string, one character at a time. Right, so in order to do that, so here we use for loop, goes from 0 to the length. So here input length, instead of this we can use stack size, stack size. So char at this method can be used. That's a character. Right. Okay, so let's for loop int I is 0, I goes up to stack size. I increase one at a time. Okay. So we push inputs dot char at. So I. Char at, if we give the index, so it will give the character at that index. So I means first 0, 1, 2, 3, likewise. From the beginning, so this is 0, 1, 2, 3. Right. Beginning, it will give char at this index, character at this index. So these characters would be taken. First W, O, R, D. Those would be pushed into, pushed into the stack. Here it is assigned to a char variable and it is pushed. But we have done that in one line, using one line. Okay. Right. So then now we have pushed all characters of that word or the that string into this. Now what we have to do is we have to do the opposite. We have to pop, right? We have to pop in pop. We don't have to give anything, but it returns a value. It returns one character at a time. So what we have to do is we have to get those pop characters into a new string. Right. See, pop characters are taken into a variable and it is appended. Is appended to output. Right. Output. We can do that in one line like this. You don't have to use for loop here. You can use just while loop if you want, but this is also fine, no problem. You can just push characters of the word one by one at a time. Index 0. Into the stack. Then pop characters of stack at a time. Append the popped character into the output string. ඒ pop වෙන එක output කියන string එකට ආමුන. ඒතර ඒක reverse විදියට තමයි මෙතන output කියන එකට ඒවා set වෙන්නේ. අර මුල් එකේ reverse විදියට තමයි. So then output is created here and then that output is returned. Okay. So if you already have a stack, so we can use this to reverse. But to reverse a word, it is easier that we can use some other mechanisms. Right? But stack can be used. Again, reverse කරන word එකක් reverse කරන්න මීට වඩා හොඳ mechanisms තියෙනවා. අනිවාර්යයෙන්ම තියෙනවා. මේක නෙමෙයි හොඳම විදිය. හැබැයි මේක පාවිච්චි කරන්න ඕන නම් පුළුවන්. So in this case, you can see, so there's a for loop. It goes the size. If size is n, suppose the size is n, so this loop goes n times, right? So here it is big O n. And then we have another loop. It goes again n times. It's big O n. Big O n. So this part is big O n. This part is big O n. But these are not. These are two separate for loops, right? Because of that, we don't say the time complexity of this variable, this program. We don't say big O n square. මේ for loop එක ගියාට n වාර ගාන ගියාට පස්සේ මෙයා යන්නේ. අර මේ nested නෙවෙයි. These are not nested for loops. So that in that case, big O n, so n plus n. It is like big O altogether. We can say it is big O 2n how it is taken n plus n. Right. If these are nested, then only we use n multiplied by n. So that's why that's how it could become n squared, but in this case, so these are independent, mutually exclusive for loops. So we add them. It will become 2n. But usually we don't consider this constant part. So again, so we consider this as this is having big O n. Big O n time complexity. So there could be some mechanisms. We can come up with some mechanisms which are better than this. So here actually big O 2n, right? 2 for loops are there. So we can do that with just one for loop, right? And to reverse strings, so there are library methods as well. So you can use those methods as well. But however, so I'm telling you here that stacks can be used. Stacks having this characteristics. It can reverse something. Right? Okay. So we can use that method or the class that we used. So let's use this class. Reverser. That can be used. New reverse. Can use string here. Sorry, word reverse. Word reverse. That's a class name. We have to give a string here. Suppose we give a string, and then if we call the method to reverse, then it will return a string, so we can print it. We can print it. So let me use a string. This one is given here, and then this print. First we print it and then reverse it. So reverse it here and then print it. So out for the return value. See, this is the word that we have given, and then it was reversed. You can take this in string from user as a user input. So here you can see enter a string, and then that string has been taken. You can use scan instead of this. So we have scanner. So this is kind of an old program, so you can use scanner Java to get that as a user input. And then if it's empty, so you can break the program. So otherwise, reverse word, reversed. Give the so get string. So this method is it is taking input stream reader and so on. But you don't have to do that. So we have easily, now we have a method scanner object, and you can using that object, you can get the input easy. So again, one more thing. So here in the constructor, we are taking the input. We are taking the input. But you don't have to do that. Again, so you can, if you feel changing that, right, like in the word reverser, we do nothing, right, like in the constructor. But in do reverse, here we can take this. Right. Then take even in a try input, this dot input is assigned with this. So if you do this, right, if you do this, you don't have to create. So every time you don't have to create a class object from this class. So once it is created, you get just one class. So, right, so every time, so we can give this into the method. You don't have to give it when the class object from that class is created. A class එකේ object එකක් හදද්දී input එක නොදී class එකේ එකපාරක් object එකක් හදනවා, method එක call කරද්දී input එක දෙන්න හදන්න. So this way would be more efficient in the sense of creating new objects every time, all the time. So in that case, we can move this line into the top here. කියන්නේ මේ while loop එකක් ඇතුළේනේ මේක මේ object හදා යන්නේ. එහෙම object හදා යන්නේ නැතුව එක object එකක් විතරක් හදලා method එක විතරක් call කරන්න පුළුවන් loop එක. Right. That's better. Okay. Any questions? So any questions from this program or from this example? The second example, delimiter meshing. So what are delimiters? So delimiters are like in our program. So we use braces. These are braces. Then brackets. braces, brackets, or parentheses. Parentheses. So these are called delimiters. Delimiter. Right. So in delimiter matching, in an expression, right? So in mathematical expression, it could be, right, braces, brackets, and parentheses. Each opening or left delimiter should be matched by the closing or right delimiter. Right? කියන්නේ මෙන්න මෙහෙම එකක් ඇරිලා තිබුණොත් ඒක වැහෙන්න. Right? Suppose in this line, right? So here this one is open and then another one is open and then one has to be closed and another has to be closed. There should be two. Okay, so if we take this, if we take this, we take this, right? So then we have different delimiters. Right? Okay. So this is open. And then this one open. And then we have brackets open and then closed here. And then the open parenthesis is closed here. Right? If I found something like this, right? Before closing this opening parenthesis, so this one is closed. This is not correct. So this is wrong, right? It can මුලින්ම මෙහෙම open කරපු එක open කරපු brace එක තියෙනවා. ඊට පස්සේ ඊට පස්සේ open කරපු parenthesis එක තියෙනවා. ඒතර පස්සේ open කරපු parenthesis එක close කරලා තමයි මේක close කරන්නේ. ඊට කලින් ආපහු මෙතන වෙන එකක් open කරනවා. ඒතර මේ open කරපු එක close කරලා තමයි make a close කරන්න. Right, so there are such rules in, right? So you can when we do when we are analyzing this kind of statement, right, then delimiter matching is important. Each opening or left delimiter should be matched by the closing or right delimiter. Also, opening delimiters that occur later in the string should be closed before those occurring, right? So this one is correct, this one is incorrect. The reason is here open, okay, open, close, then close. Up to this, it is fine. And then, so we have right delimiter here, which is not matched with any opening words. So if you are given this kind of statement, whether you want to check it is correct or incorrect, you can use stacks. You can use stacks. It's very, very simple. The idea is very simple. Right? So we have a stack. Again, stack, a char stack can be used. Char stack can be used. Right? Suppose this one. Okay. Oh, this one. Right, okay. Right. So here we check 4 delimiters. We go one by one, and if we find a delimiter, it could be this or this or this, or it could be one of these characters. If we find one of these characters, so then other characters can be ignored, right? Then if we find left or opening delimiters, any of these, if we find any of these, we put them into the stack. So here, in this case, first we find this brace. Okay, we put it into the stack. And then this one, and then again we find delimiter, opening delimiter, so we put it into the stack. And then if we find any of these, if we find opening ones, we push. If we find any of these, we pop. Pop the top one. Suppose now we are having closing bracket. Then what we do is we pop the top. We pop the top one, which is this. So we pop that and we check whether it is matching with the delimiter that we are having. Then after that, the may will be in the make it. In ඒකට හරියන එකක්ද මේ පොප් උනේ කියලා බලන්න. මේ දෙක මැච් වෙනවද කියලා බලන්න. يعني මේකේ ඕපනින් එකද මේ තියෙන්නේ. එහෙම මැච් වෙනවා නම් ඕකේ. Okay, no problem. Up to now, no problem, right? So now it is, they were matched. And then we put the next one, and then again we find closing or right delimiter. If it is right delimiter, we pop. So we pop this one. We check, okay, so these are matching, so no problem. And then we go to the next one. We don't find any other delimiters and the stack is empty. Then no problem, this is correct. Right. Let's take the other one. Okay, so let me write it back, right? So A, B, C, D, E. Okay, right. So we analyze this. Go one by one, and if it is opening one, we push. And then again opening one, we push. Then closing one, then we pop. We pop. We pop. And we check whether it is matching with this one. Yes, they are matching, so no problem. We go to the next one. Next one. Okay, again closing one, we pop. We pop. Closing on this one. We pop. They are matching, no problem. Okay. So then closing one, right? So we have closing one, then we pop. But to pop, we don't have anything, it is empty, nothing to be popped. So then we have a problem, not matching popped item. So that means, so that's why it is called this not correct. So in this program, you can see so the class name is bracket checker. Bracket checker. So we have an input string. No output string because we have to just give whether it is correct or not. Similarly, it's a constructor. So we give the input string. And then there's a method to check. You get the length. And then we create the stack. We go on a for loop. So the stack size can be used here. Up to this point, it is the same as the previous example. And then we get the char add. Then we have a switch. We have a switch. We check this character 3 cases. So if the character is any opening delimiter. If it is an opening delimiter, we push. See, we push. Can make cases තුනටම පොදුවේ අපිට කරන්න පුළුවන් මෙන්න මේක. Push. And the break. And then if opening, so closing braces. Can make opening A1 push kara, closing A1, page. So we check whether the stack is empty. Stack is not empty. If stack is empty, we give error. Right. Stack empty natta. If stack is not empty, so we go into this one. We pop. So we pop. And then the pop item is assigned to this variable, chx. Our original value is in ch, and then the popped item is in chx. So then we check whether ch is this one, if then ch is this one. Right? Can මෙහෙම උනේ නැත්තම් ch එක මෙහෙම වෙද්දි chx එක මේක උනේ නැත්තම් හරි, or if ch is this one, chx is not this one, or ch is this one and ch is not this one. If this is not happening, we give that it is an array. So it is. So there's a problem there. There's an error. Or if the stack is empty, but still we have values. So again, we give that it is an error. So somehow after looping, still stack is not empty, error. So we give error again. Can we ඔක්කොම අපි check කරාට පස්සේ stack එක empty නැත්නම් එතනත් error එක. So all these errors are given. Right? right? So that is how we do that. So I'm not going to write the program, right? So this is not returning any value, it is void, but you can return true or false based on these results. So I'm not going to write the program, I'm not going to show that, but I just show you how to do this. And then, so you can use in this class that delimiter matching class has been tested. So bracket checker input, and then method has been used. Right. Okay. So, any questions? Any questions regarding these examples? Any questions? Anything? It doesn't have to be these examples, but overall on stack. So if you know this, so that's all, right? All the other things that I explained were implementations. Right? So this is implementation, how we use them. These are only two examples. There are many advanced users of stacks. And stacks පාවිච්චි කරන ගොඩක් advanced programs තියෙනවා. Advanced situations තියෙනවා. මම මේ දීලා තියෙන බොහොම simple examples. Right. So then, if you don't have any questions, we can move to queues. Right. We can move to queues. Queues are very common these days, right? I mean, I'm pretty sure you have been in queues, right? Like we have for gas cylinders. We don't call them gas cylinders anymore, so we call them bombs. Right? I never heard such things in my life. So I have lived almost twice than you guys. So I never heard such things. But some ministers, they say like it is very common, like gas cylinders are acting as bombs. Right? So like, so we have gas cylinder queues, and then kerosene, like Bhumitel, and then to buy things, so there are queues, right? for almost all the things now, so we are having queues. Right? So today we are going to learn the basic idea of a queue in computing. So like Sri Lanka, most of the queues that we can see, they don't, sometimes they don't follow the principle of a queue. The queue has a principle. The basic principle, what is that? It is FIFO. So FIFO means first in, first out. Or sometimes we call first come, first serve. Right? If you are in a queue, the first person who are in the queue should be given the gas cylinder first. So that's the basic principle. So most of the queues in Sri Lanka, so they don't follow that principle. So the Lankaවේ අර සමහර කට්ටිය අර නිවුස් වල එහෙම පෙන්නනවා දැන් හැමදාම වගේ මේ queue එකේ ප්‍රශ්නයක් වෙලා. මොකද ප්‍රශ්නේ මේ අර මැදින් ඉන්න වෙන queue එකට ඉස්සරහින් ඉන්න මිනිස්සුන්ට දෙන්න නැතුව අර වෙන පිටින් ආපු කට්ටියට මේ gas cylinder දීලා. ඒ කට්ටිය කෑ ගහනවා. මොකද queue එකේ principle එක follow කරලා නැහැ. මේ queue එකක් තියෙනවා. ඒ queue එකේ principle එක follow කරලා නැහැ. The principle of the queue is first in, first out. FIFO. Right? So in stack, right? First, so last in, first out. Last in, first out. But in queue, the concept is something like this. First in, first out. So in that case, we cannot use just one end of the data structure. So we have to use both things. Kapathakin make a insert කරද්දී අනිත් පැත්තෙන් තමයි එළියට ගන්න වෙන්නේ queue එක. හරි? Right. So the queue so we have the principle FIFO. First in, first out. So when we draw the cut, again, this is an abstract data type. So we give the idea. So Q should be this. Then we can implement it in a different ways, right? So when we draw that, so we insert from one side, right? This is the first one, this is the second one, and so on. This is the third one. So then first, so we let the first person in first. First in, the number one is served first, right? So that's the idea of the queue. ලංකාවේ පෝලිම් පයින්නවනේ ගොඩක් තැන්වල. සාමාන්‍යයෙන් කැන්ටින් එකේ නම් ඒක වෙන්නේ නැහැ. කැන්ටින් එකේ දැන් ඔකට තාම මේ අර යුනිවර්සිටි එකේ මම හිතන්නේ සතියක් දෙකක් හිටියේ නේද? සාමාන්‍ය කැන්ටින් එකේ පෝලිං පනිනවා කියලා කතාවක් නැහැ. කැම්පස් එකේ කැන්ටින් එකේ. හරි එතකොට සමහර වෙලාවට දැන් අපි ලෙක්චර් කෙනෙක් වගේ આવොත් විතරයි ඒ කට්ටිය අපිට මේ දෙනවා ඉස්සරහට යන්න මේ එහෙම නැත්නම් එහෙම පෝලිං පනිනවා කියලා එකක් නැහැ. හරි මේ එතකොට දැන් ඒකත් අපි ඉගෙන ගන්නවා. priority එක වෙනස් එක්කෙනෙක් આવොත් මොකද්ද කරන්නේ? priority queues. It's right. එතකොට මේ දැන් ඒතරේ ප්‍රින්සිපල් එක සාමාන්‍ය කැම්පස් එකේදී ගොඩක් වෙලාවට දකින්න. ඒ කියන්නේ queue කියන එකේ ප්‍රින්සිපල්. එතකොට මෙන්න මේ අයිඩියා එක කොහොමද අපි ඉම්ප්ලිමන්ට් කරන්නේ? ඒක තමයි බලන්න. So in queue, we have to check, we have to see the operations, right? So mainly, like in stack, we call pop, so push and pop. Here we don't call them something different, so we just call insert or remove. Insert, remove. We can use peek as well, but that's not mandatory, right? Insert and remove. Right. Person join the queue at the rear. Person leave the queue at the front. Right. So here we have to maintain two ends. What is the front and rear? Front and rear. So in our previous case stacks, we just maintain only the top. Where is top? Where is top? That's enough. Top කියන මේ position එක කොහෙද තියෙන්නේ කියන එක අල්ලාගත්තොත් ඇති. But in queues, we have to maintain both front and rear. Front and rear. Queue එකේ කොහෙද ඉස්සරහා කොහෙද පිටිපස්ස. ඔය දෙකම මොකද පිටිපස්සෙන් තමයි කට්ටිය එකතු වෙන්නේ. ඉස්සරහෙන් තමයි කට්ටිය එළියට යන්නේ. එතකොට මේ දෙකම අපිට ඕන. So like this. Front and rear. Both positions has to be recorded. Right. So two variables are necessary. Yeah. Okay. Queues are used as programmer tools as stacks are. Similarly, queues are again used as mainly as programming tools. Queues help for searching graphs. If you are using in graph searching algorithms, queues are used. They are also used in model real world situations. Like stacks are not mostly used in real world situations, but queues are. Queues can be used to model this kind of situations, like people waiting in line at a bank. Right? Suppose people are waiting in a line at a bank. So if you are going to create an application to handle that situation. So if you take a number and then you are waiting, right? So you can sit somewhere and then your number would be called automatically using a program. In in many banks, that is not many banks, but in some banks, that similar systems have been implemented. So I don't remember exactly where I experienced. But sometimes when we are waiting for doctors, this kind of applications are there. So next number, so is this, right? So you have a number for doctor's appointment, and then that number would be displayed on the screen. So you are next. So then you can go to meet the doctor. So likewise, people waiting in a line at the bank, airplanes waiting to take off. That's another situation. Data packets waiting to be transmitted over the internet. Right. So data is transmitted as packets. Right. So those packets are kept in a queue and then transmitted over the internet. In these situations, in programs, queues can be used to handle this. Can anyone tell me similar situation that you have experienced? Queues. So, can anyone tell me some other examples for queues? Or can anyone suggest something? Like there are many queues for different things, like for to get milk, right? මේ ළඟදි කාටද අර මිනිස්සුන්ට ඌ කියලා තිබ්බේ මේ එහෙම පොලිමක හිටපු කට්ටිය. So can you suggest something? Salon. Yeah. So they have queues. Yeah, good suggestions, Arfad. I don't know whether I haven't seen any like for salon, like we are waiting in seats. Sometimes there could be problems. Yeah, good suggestions. Yeah, Johan, in operating systems, process queues. Yes, exactly. Process queues, so they use that. Actually, process queues, so they use priority queues, like advanced type of queues. Based on the priority, the chance is given. Right? So we are going to talk about that as well. Okay, thank you. Any other situations? So I saw in recent news that one of these queues for milk. So tokens were issued. Tokens are issued. So based on those tokens, they can come to buy milk, right? It is manual, but actually we can make a very simple application to do that. And another very favorite, very common queue for vaccines. Vaccines also nowadays it is like most of the people are fully vaccinated, so it is not, there are no much queues, but can you remember like a few months ago, and there are long queues. Like I remember when I am traveling from like Boralesgamu area, like 1 or 2 kilometers queues. So mostly like old people, like in such cases, sometimes like we, then some people, they try to implement this using a system. They generate a time, and then based on that time, they can come. Tokens are issued likewise. So if anyone interested in creating some applications, simple applications for queues, so those would be very useful in this year, mainly in Sri Lanka. There will be more queues for many things, many other things. To buy very basic things, there will be queues. So anyone can create an application, simple application, and then you can give it to some authorities, and then you can make it useful, right? So keep that in mind. Huh? Right. Sorry. So these are real world situations. Real world situations, in real world situations, we can use queues. So also queues are used in as internal mechanism in most of the situations in computing, networking, or operating systems. As Johan said, like process queues, and then printer queue, where print jobs wait for the printer to be available. Right? So printers, they have queues. And then keystroke data as you type at the keyboard. When you type keys, so those keystrokes are kept on a queue. The first come, first served. So first pressed, first type, the first displayed or something. Keystrokes. So there are many situations that queues are used. As I told you, so we have insert, remove, rear, and front. Right. So now, so let's take maybe 10 minutes break. Let's take 10 minutes break, and we will meet in it's around 10:50. 10:50. Huh? So let's take 10 minutes break. So I will have a hot water and come back. And you can drink a tea or whatever, and drink water, and you can come back in 10. Okay. So